everybody. This is Eric Tang from LivePeer. I'm really excited to be here at Demuxed this year virtually, talking to you about content classification for live streams with ffmpeg. Before we dive into some of the technical details, I want to share a little bit about why we're working on this problem. If you work in live streaming, sometimes you see usage graphs like this, right? All of a sudden, all these users came to your platform and started watching video streams on your platform. Well, this can be a good thing if you know that you're hosting a large event and you're expecting all these users. But sometimes if you start to receive emails like this, which is a DMCA takedown, you start to realize, well, maybe something else is happening on my platform, right? Even worse, sometimes you only realize after the fact that someone has used your platform to stream something like a Premier League soccer game that then went out to thousands or tens of thousands of viewers on the internet. And this, can be bad for your platform in many different ways. And this happens quite often in today's, UGC-centric live streaming world. It's a tough problem to solve. When you're small, you can still kind of solve it manually. But when you get bigger and bigger, when you have millions of users, you need to do this at scale from a fundamental technology perspective. And that's when I think video AI really start to come in handy, right? It can start to help you automate a lot of these things. So let's take a look at what video AI can do, right? There's all kinds of things. It's really powerful. We can do upscaling of grainy images to make them more crisp. We can do denoising of videos to remove rain streaks or fogs. We can do object recognition, metadata extraction, hundreds of different use cases. So for our use case, we can think about things as a classification problem. If we can classify the type of videos that come into our platforms, then we can start to build custom logic in the backend to start automating these types of workflows. And of course, this is a pretty interesting video processing problem. And as video developers, when we think about video processing, the next logical step is, can I use ffmpeg to do this, right? ffmpeg is really popular. It's really powerful and it does a million things. There must be something in there that can help us address this issue. And if you think that, you'd be right. There are some interesting AV filters that are in ffmpeg. And in fact, this is one of the most rapidly evolving portions of the code base. Let's take a look at what's been happening in the past couple of years. In 2018, the first AI filter was introduced that allows you to run any kind of deep neural network backend, and this was the SuperResolution filter. Soon after that, the deep neural network backend was factored out so that we can introduce other types of backend, and then TensorFlow was introduced. In 2019, the Derain filter was introduced to the code base on top of the TensorFlow backend as a part of Google Summer of Code. 2020, OpenVINO was introduced, so we start to have different types of DNN backends. In 2021, only this past summer, there was a pretty big refactor so that now we can do async mode for TensorFlow to make it much more performant. And let's look at some of the AI filters that are available today, right? We can do deinterlacing, we can do Derain, we can do SuperResolution, but we can also train custom models to run both classification and detection, and also image processing, right? So we can load our own models into these backends. And that's all great. So when we started looking at this problem, we really thought about, can we just use existing solutions to help us do the content moderation? And unfortunately, we couldn't find anything that quite fit our use case. And this is because we want to do this for live streams in the UGC case where thousands of concurrent streams can be happening at once. And we want to be able to do this really effectively and really scalably. So in order to do this and solve this problem in this context, we started looking at GPU architectures. Most of the videos that happen on the LivePeer network get transcoded on the GPU, right? So if you look into how the GPU works, we have the encoder and decoders that are ASIC chips that can only do those things, but we also have the processing chips, right? And those processing chips are really good at computation, especially for training machine learning models and doing inference. So if we can try to fit everything onto the GPU at once and do everything in one go, then we'd be able to really lower the overhead and make things really efficient and cheap. So let's look at whether this is possible, right? If we zoom into the bottom, this is kind of ffmpeg land GPU stuff, right? We have the AV frames going into the decoder. We have the raw video coming out of the decoder going into the scale filters. The scale filters would scale the video down into the different bit rates and frame rates and different sizes that then get sent into the encoder, repackaged into something like HLS or Dash, and that gets sent to the users. So in this filter graph, it would be nice for us to just introduce another AI filter that also lives on the GPU, right? And things can kind of happen in parallel so that encoding and decoding and AI filter can all happen at the same time. So in order to do this, we had to build a custom AI filter. To do this, we did a couple of things. One is we trained our own model in order to detect soccer streams and adult content. We used MobileNet v2 for a really fast and lightweight performance. We trained the model using about 80,000 frame images. And after some experimentation, we found that a 224 by 224 input size was the optimal trade-off between the inference performance and model accuracy. We did have to distort the video a little bit in order to fit something into a square, but we found that this worked pretty well. It took about 2 days to train this model. We also had to pick a DNN backend, and for this, we picked TensorFlow because we wanted to run on the GPU. The DNN backend code in ffmpeg is pretty nice. It gives us an opportunity to do pre-processing and post-processing. So for example, the pre-processing step is where we shrink the source image down to the 224 by 224 input size in order to feed into the inference model. So this is the architecture that we ended up with. We have an AI filter that takes in the input. That filter triggers the model to load in the inference backend. And once that model is loaded into the inference backend, we can send inference requests and get inference results back. And those inference results can be sent alongside of the raw video as side data into the metadata publisher that then gets pushed down to the filter graph. After doing the engineering work, we did some benchmarking, and this is done on a RTX 4000 card, which is a Quadro NVIDIA card. And what we found is that, depending on the sample rate, we can do about 15 concurrent video streams transcoding full ABR ladder HD while doing classification at the same time. And that only takes about 40% of the GPU. So we were pretty happy with that result. Let me show a quick demo of how this works in practice. So here we see that I'm streaming Big Buck Bunny. We're getting the results back via webhook events. And here we see that the model thinks there's no soccer. When we start streaming soccer, we see the probability of soccer going up, going now to about 99%, right? It thinks that it's soccer. And after that, when we turn the soccer stream off and go back to the Big Buck Bunny video, we see that the probability going back down to 0. So this all works, and it works great. So what's next? One interesting thing is that because this is all implemented as filters, we can start to chain these filters together to do some pretty complex and interesting workflows. For example, after the classification, we can send everything into a content recognition filter that then gets sent to a object replacement filter. Then we transcode the video. So for example, this can allow us to do some pretty interactive videos that can in real time replace objects in the video, or we can do things like ad placement in the raw video itself. Another thing that we want to experiment with is loading more dynamic models in real time. Right, this allows us to scale this workflow even more. So for example, we can do classification at the beginning, find out what type of video it is, and then load different models according to the type of video in order to do any kind of manipulation on the video. Finally, everything that I talked about today is open source. The data, the training script, and also the model itself. Everything's open source. So if you're interested in taking a look at it, if you have content moderation needs for yourself and you want to use this, absolutely take a look. And because everything's open source, we'd also love to collaborate with the community in order to continue to improve the model, continue to improve the data, and also to build new models in order to classify other types of content. So thank you very much for your time. I want to give a quick shout out to Jay, Oscar, Ivan, and Philip on the LivePeer team for doing the research and engineering work around this problem. I want to do a quick shout out to JB and Xuewei from the ffmpeg team for some ffmpeg archaeology questions. And also Ra, Ignacio, Jesus, Yandan, and Eli for reviewing this talk. If you're interested to get involved in any way in this project, if you want to use it, shoot me an email at eric@livepeer.org. Happy to talk to you. Thank you.